Good morning, everyone. This is now the continuation of our discussion about the advanced sorting algorithm in Java programming. So under insertion sort is a simple sorting algorithm. It builds the final sorted array one item at a time. It is much less efficient on large lists than other sort algorithms. Advantages of insertion sort. First, it is very simple. 2. Second, it is very efficient for small data sets. Third, it is stable. It does not change the relative order of elements with equal keys. Fourth, in place, only requires a constant amount 1 of additional memory space. Insertion sort iterates through the list by consuming one input element at each repetition and growing a sorted output list. On a repetition, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. It repeats until no input elements remain. So, this is the sample of insertion sort. So, the first element is unsorted. What we are going to do is to sort them all. So, the first two elements is unsorted. So, we need to swap the two elements. Yung 2 mapupunta sa left side. So, nandito na yung pwesto ng 2. And then yung 5 mapupunta sa right side. Bale, nagkapalit lang sila ng pwesto. So, the output will be look like this. 2, 5 is sorted na siya. Then, ang next na naman na number na ating sort is yung 4 and 5. Yung 4, mag-i-insert doon between 2 and 5. Kaya nga, insertion sort na tinatawag. You have to insert number or item. So, yung 4, i-insert natin between 2 and 5. So, ang mangyayari, yung 4 mapupunta sa left side, yung 5 mapupunta sa right side. So, ang output ay magiging ganito. 2, yung in-insert natin 4 between 2 and 5 ay nandito na. 2, 4, 5. So, sorted na sila. Tapos, yung 5 and 6, okay na yan. Sorted na yan. Wala nang dapat i-insert or isingit sa gitna. So, ang isosort na naman natin na element is yung 1. Paano? So, yung mga numbers na ito is mag-a-adjust. So, yung 1, magtra-transfer siya dito pa left. Mauuna sa 2. And then, mag-a-adjust pa right side ang ibang numbers. So, yung 1 mapupunta dito, may insert, madadagdagan ng ibang pwesto at mag-a-adjust yung ibang numbers. So, ito, yung 1 is nandito na. Then, ang susunod na naman na ating isa-sort is yung 3 kasi unsorted siya. Yung 3, isisingit natin dito kasi yun yung kasunod ng 2. So, madadagdagan ulit ng panibagong pwesto at mag-a-adjust ulit yung tatlong numbers. So, kapag nagawa na natin yon, ganito na ang magiging output. Yung naisingit na 3 ay nandito na. So, ang magiging output nito is lahat ng numbers na unsorted ay sorted na dito sa bandang huli. Naisingit na yung 3 dito between 2 and 4. 2 and 4. So, 1, 2, 3, 4, 5, 6, sorted na lahat yan. Ganon ang insertion sort. Insert. The best case input is an array that is already sorted. In this case, insertion sort has a linear running time. During each iteration, the first remaining element of the input is only compared with the rightmost element of the sorted subsection of the array. The simplest worst-case input is an array sorted in reverse order. The set of all worst-case inputs consists of all arrays where each element is the smallest or second smallest of the elements before it. In this case, Every iteration of the inner loop will scan and shift the entire sorted subsection of the array before inserting the next element. This gives insertion sort a quadratic running time. The average case is also quadratic, which makes insertion sort impractical for sorting large arrays. However, insertion sort is one of the fastest algorithms for sorting very small arrays, even faster than quicksort. Indeed, good indeed, good quicksort implementations use insertion sort for arrays smaller than a certain threshold. Also, when arising a subproblems, the exact threshold must be determined experimentally and depends on the machine, but is commonly around 10. So this is the sample. The, so this is the sample program of the insertion sort. So if we are going to run this program, this will be the output. Quick sort or partition exchange sort is a fast sorting algorithm which is using divide and conquer algorithm. Quicksort first divides a large list into two smaller sublists, the low elements and the high elements. Quicksort can then recursively sort the sublists. Step to implement quicksort. First, choose an element called pivot from the list. Generally, pivot can be the middle index element. Second, reorder the list so that all elements with values less than the pivot come before the pivot, while all elements with values greater than the pivot come after it, or equal values can go either way. After this partitioning, the pivot is in its final position. This is called the partition operation. Third, recursively apply the above steps to the sublist of elements with smaller values and separately the sublist of elements with greater values. So this is sample of the quicksort. So so what we are going to do is to swap 5 and 4. 5 and 4. So yung 5 mapupunta sa right side and yung 4 mapupunta sa right side. So magiging ganito ang output. 3, 7, 8, 4, 2, 1, 9, 5, 5. Yung 5 napunta dito sa right side. So, ang next na naman na ating i-sort ay yung 7 and 4, 8 and 2. So, ganito ang magiging output kapag nag-swap ang elements na ito. So, 3, yung 7 mapupunta sa right side and yung 4 mapupunta sa left side. So, magkakaiba sila ng pwesto. Magkakapalit lang sila ng pwesto. So, 3, 4, ito yung magiging output. 3, 4, 2, yung 2 nandito, 7, 8, 1, 9, 5, and 5. So, ang next na naman na element na ating sort ay yung 7, 1, and 8, and 5. So, ganito ang magiging output. Yung 7 mapupunta sa left side, mapupunta sa right side, at yung 1 is mapupunta sa left side. So, ganito ang magiging output. 3, 4, 2, 1, 5, 7, 9, 8, 5. And then, ang next na naman is yung 8 and 5. Yung 8 mapupunta sa right side, yung 5 mapupunta sa right side. So, ito na yung magiging output. So, hindi pa siya final. So, ang last is yung unsorted na 2 elements, 7 and 5. So, yung 7 mapupunta dito sa right side and yung 5 mapupunta sa right side. So, yung 5 na ito ay yung magiging index ng mga elements na sorted. 1, 2, 1, 2, 4, and 3. is okay na yan. Sorted na sila yung 3, 4, sorted. 1, 2, sorted. 5, 5, okay lang yan. 9, 8, 7, or 7, 8, 9, sorted na sila. O ano lang yan. Kumbaga, nag-vice versa lang sila. Pero ang index is yung 5. The complexity of quicksort in the average case is 0, n log n, and in the worst case is 0 and 2. So this is the sample program of the quicksort. So if you are going to run this program, this will be the output. Merge sort is a divide and conquer algorithm. Steps to implement merge sort. First, divide the unsorted array into n partitions. Each partition contains one element. Here, the one element is considered as sorted. Second, repeatedly merge partition units to produce new sublists until there is only one sublist remaining. This will be the sorted list at the end. So this is a sample of merge sort. Merge. So as we notice above, the elements is unsorted. So what we are going to do is to divide all of them into 2. So divide natin sila ng dalawa. So ito yung magiging output. Dalawang grupo. Yung dalawang grupo, i-divide mo na naman sila kanya-kanya sa dalawang grupo ulit. Yan. Then, next na naman, ganoon na naman ang gagawin. So, dito mapapansin natin, nagiwalay na yung ibang numbers. So, separated na silang lahat. So, dito sa bandang taas is unsorted lahat yan. Kahit na-divide na sila. Dito sa gitna, unsorted na naman. Pero dito sa pinakababa, sa mababang part, dito na masosort yung mga elements. So, ito, magma-merge lang tong dalawa. Then, magma-merge ito, magma-merge. Ito, walang kasama kasi nag-iisa. Then, itong lahat, magma-merge ulit yan sa dalawang grupo, magma-merge. Pero, kahit na nag-merge sila, kahit nag-merge yan, sorted na yan. So, itong dalawang grupo, magma-merge ulit yan. So, ito sorted. Pero mag-merge yan para maging sorted sila as a whole. So, yung 3, susunod niya is 9. Nandiyan na. Then, 10, 27, 38, 43, then yung panghuli is yung malaki is 82. So, dito, sorted na siya. Ito na yung final output niya. Merge sort is a fast, stable sorting routine with guaranteed 0 n log n efficiency. When sorting arrays, merge sort requires additional scratch space proportional to the size of the input array. Merge sort is relatively simple to code and offers a performance typically only slightly below that of quicksort. So this is the sample program of the merge sort. So if you are going to run this program, uh, uh, the output will be like this. So ito na. Thank you for watching and listening.